Yeah. Hi, everyone. Welcome to our webinar, Understanding AI Agents and Agentic Systems. And welcome and thanks for joining, everyone. Today's webinar will be hosted by Pavan, who's like a senior developer evangelist here at SingleStore and has been a great asset to us in terms of technical knowledge and product use cases. So, he's a subject matter expert on this following topic. Uh, Please reach out to us if there's any questions, if there's anything that we can help you out with. You are currently in a listen only mode, so you can interact with us using the Zoom Q&A button, which is present at the bottom of your console. And please utilize it because we will be having a dedicated Q&A session towards the end of the webinar. Stay tuned for that, and you can always drop in any of your questions if there's any project that you're working on, or even if it's anything general. We'd love to interact with you. And yeah like so We basically have a few rules as well. I will be sharing everything in the chat, so keep an eye out. Like, if there's any resources, we are currently offering $600 worth of free credits for anyone that signs up, using like the link that I'm going to provide. You can sign up and follow along in real time to make the best use of your time. And as for me, I'm Yukti, and one of my main jobs here at SingleStore is to run these webinars and like bring them to you. And we have amazing webinars that are also coming up. So yeah, stay tuned for that. And thanks for joining. Pavan, please take it away.
Yeah, thanks, Yukti. Thanks for that. Let me minimize this. Hey guys, thanks for joining. Today's talk will be all about understanding AI agents and agentic applications. Without any further ado, let's get started. This is me, Pavan Belgatti, and I'm currently working at SingleStore as a technology evangelist, and I'm also one of the top voices in AI. I keep posting a lot of content around AI on LinkedIn, YouTube, and on many other publications. Yeah, so that's about me. And For today's talk, this is the table of contents. We're going to talk about the evolution of AI systems. We'll talk about LLMs and limitations, what limitations these LLMs have, and we'll also talk about techniques to improve these LLMs, AI agents architecture, AI agent categories, core features of AI agents, and then we'll talk about what exactly is agentic AI. And To build a simple demo or a tutorial that I have shown, I'm going to use LangGraph. I'll also talk about LangGraph, why I'm using LangGraph and what exactly is LangGraph. And at the end, I have a simple AI demo that I'll show. So let's get started. So since we're talking about AI agents and agentic AI, I think some days back I went to Google Trends. If you don't know what is Google Trends, it's a platform where, from Google, where you can see the trends of different keywords, how they are behaving over time, how people are interacting with them, and how many people are searching them and talking about them. So this is how you can see, AI agents and agentic AI for these two terms. I think after June 2025, you can see a big spike, right? Because of all the reasons, because we know every company now and everybody wants to learn and build AI agents and agentic AI applications for all the good reasons, right? So that's what you see here, a big bump in how people are talking about these two keywords. You can go to Google Trends and try to see it for many other trending topics like MCP and many other trending topics. The main idea of this slide was just to show you how why we are talking about AI agents and agentic AI systems today. And Yeah. I also went to SEMrush. It's a platform to find the keyword search volume for different keywords, and it will also help you with SEO, search engine optimization. So again, I went here to just to see how these two keywords are doing. I saw the keyword search volume for AI agents and did the same for agentic AI. As you can see, the monthly search volume for AI agents is 27.1K. That's huge. And then now, since agentic AI is all the buzz, you can see for 49.5K monthly search volumes around the globe. And the global search volume you can see for AI agents, the first is India, US, Taiwan, and many others, right? And agentic AI, it is US, UK, India. You can see, and also you can see the cost per click rate that is $12.59 and almost similar for the agentic AI. And also you can see the keyword difficulty 98% and 83%. That means these two keywords are very difficult to rank for on Google if you try to write anything on them. So yeah, and this is a picture of the evolution of AI systems so far. We started with simple basic LLMs from OpenAI, Claude, Mistral. Um, they used to give the input and they used to give us the on output. It was all simple. We tried to build some assistant chatbots, but then we thought, you know, there is no custom document attached because we want to build custom chatbots, custom applications. Then we tried to augment our own custom data into these LLM applications. That's where we called such applications as retrieval augmented generation applications, right? The whole process, retrieval augmented generation. And then from there, we move to AI agents with little autonomous systems where they try to do everything by themselves. And now here where we are like agentic systems where different AI agents coming together to help you solve very complex problems, right? Yeah, I mean, if you take X axis for capability and Y axis for autonomy, this is how it goes. So we are at the agentic systems now, and everybody is talking about agentic systems. But let's start with the basics, right? Let's start with what are LLMs, understanding LLMs. LLMs are made up of like data, structured, unstructured data, anything on the internet, Wikipedia, YouTube, content, and all that. And then the architecture, the transformer architecture proposed by the researchers at Google, and then some kind of training, supervised, unsupervised, and reinforcement training. That's how an LLM is basically made up of. But you can't use them directly into your applications because these LLMs have limitations. What are those knowledge cutoff dates? See, all these LLMs have date till that time they are trained. But if you ask them something very recently, what happened, like what is the current weather, but now they will give, but sometimes they usually hallucinate, right? They usually don't give you the current affairs responses properly, and they hallucinate. Like I said, they might come up with their own responses because there is no way you can verify the responses. Now that the LLMs are very sophisticated, they can do easily tool calling and easily get the current live data. But usually, knowledge cutoff date is one of the limitations, and hallucinations is one of the limitations, and they don't have access to your custom data, proprietary data, and that is one limitation. And also they all have this context limitations, right? They don't remember much, limited context window size. So these are some of the important limitations that LLMs usually have. But then how can we overcome these limitations? So these are the techniques that we usually use. One is prompt engineering, the art and science of working with talking to your LLMs, basically defining output, input properly, and then seeing the output, and then making sure what type of adjusting the input, and again seeing the output, right? It's all about prompt engineering, and then comes fine tuning. Fine tuning is where you take a base model and then you try to train that with your custom data so that it starts understanding your vocabulary, right? So, but with fine tuning, you need to have, computing resources, and it is kind of costly, and also you need people to fine tune the base model, and that's why it is little costly. That is where usually RAG is the recommended one, retrieval augmented generation, where you can easily augment your custom data to the LLM using a vector database so that the LLM doesn't hallucinate. It can easily go and fetch the proper data from a vector database using vector search or semantic search, right? So, but they all share a common limitation, right? All these techniques, what is that? They only optimize a single shot of reasoning. So they don't usually act autonomously. You need to go. Usually, this is what happens, right? When you talk to ChatGPT, hey, do this, change this, update that. It doesn't take, every time you are going and giving the instructions. That is where we see a transition from LLMs to AI agents, where agents are systems that independently accomplish tasks on behalf of you, on your behalf, right? So AI agents are basically the systems that can easily perceive, the user input, what the user input is, what the user prompt is. They can reason and they can actually act accordingly, right? They can do tool calling. Hey, the user input is this, the user prompt is this. Let me do the tool calling because the user is asking the weather in Delhi, weather in Boston. So let me do a tool calling of the weather tool, weather API calling, and then it'll. This is how it takes its own decisions and does all the tool calling, API calling whenever required, and then it gets the work done. So you are not there every time, giving instructions. So that's how AI agents basically work on behalf of you. So this is a simple architecture of AI agents where you can see there are tools, LLM, which is the brain of the agent, and it can take actions. There is a memory, short-term and long-term memory, and then there is planning, right? They also do planning like good goal decomposition, reflection, and critic. So whenever the AI agent gets an output, they can easily do critic their own output, saying, hey, is the output satisfactory? Should I go back again, iterate the whole thing? Should I do it again? So that's how AI agents basically work. So this is a simple example of an AI agent in code format, the weather agent. The name is weather agent, and there is a system instruction saying you are a helpful agent who can talk to users about the weather. So this is simple Python code format. And in agent, there are categories. One is single agent system and multi-agent system. As easy as it looks, right? As the name suggests, there is one agent with all the tools connected. Only one agent does everything. And then in multi-agent system, there are multiple specialized AI agents coming together to help you, solve a complex problem, which is kind of a distributed workflow. And these are the core characteristics of an AI agent: the autonomy, the task specificity, and then reactivity. Autonomy is nothing but there is minimal human intervention. You don't go again and again with your prompt to make sure. Once you set up your AI agent, that is done. It does everything by itself, right? Because it understands what you're asking, the prompt, and then it does the task decomposition. It gives those subtasks to the other agents, and that's how it basically does the tool calling and all those things. And task specificity is nothing but narrow, well-defined tasks. It does that properly, and then reactivity, responding to changes. So it is kind of dynamic. If it feels like the answer, like I said, if it feels like the answer that it has generated, the response, if it doesn't feel right, it can always go back, critic, and reflect back, and then reiterate on its thing dynamically. So that's the reactivity part. So here's a simple example, AI agent in practice, example of an AI tutor assistant. There is a UI where usually you think that it's for like students, school students. There is a UI and there is a LLM. There is a system message. The system message is like you are an AI student tutor. Your role is that of helping students in understanding a complex problem topics. And then there is an orchestrator. There is an orchestration layer where you can see we have used LangChain. LangChain is nothing but a framework, LLM framework, to help you build uh, LLM powered applications, right? Uh, you see LLM, system message, knowledge base, tools, memory. So all these things can be easily connected using something like LangChain and LangGraph. Otherwise, it would be very difficult for your developers to hard code and connect everything, right? And see, there is a memory where students' past exam history, his strengths, weaknesses, and everything will be present. There's a school's reference manuals in the knowledge base, and there is in the tools you can see the school's calendar where the student can easily go and book the next session, right? So this is a simple example where the student can easily try to talk to this system, understanding different complex problem, topics, understanding different topics. So that's a simple example, and here is a simple differentiation between LLMs versus AI agents. LLMs, what they usually do is they predict the next word. That's the thing they do, but AI agents do things. They can do tool calling, they have the memory, they can talk to the tools, the other agents, and they can take actions basically. They can do, planning and all those things. Mm, and this is the journey so far to the agents. It all started with single LLM features where they started doing summarization, simple linear Q&A, simple chatbots, right? You gave an input and then the LLM processed the output. And then came workflows where we gave context through RAG, retrieval augmented generation, and then we started seeing these workflows by creating some custom RAG applications and LLM applications. And then now uh, here where we are with agents that LLMs deciding their own trajectories. Hey, the user is asking this, let me pick that, let me do that, and they can take their own actions and reason and then critique their own responses and do all this in a loop until the response is satisfactory. So this is simple again, the journey to agents from LLM to RAG to agents. And so the future of AI is agentic. So let's talk about agentic AI. We understood what are AI agents, how they work, what are the different components of AI agents. Now it is about agentic AI. So when I talk about agentic AI, we need to understand one thing in the word agentic AI. It's important to understand what exactly is agentic. It means agency. That means the capability to act independently and take actions autonomously, right? And that's exactly the meaning of agentic in agentic AI. So as you can see, agentic AI companies are on the growth trajectory. I think some days back I got it from I don't know, somewhere I got the screenshot and on Twitter, I saw this. So, as you can see, Lovable is one of the agentic AI companies that crossed from 1 million to 100 million ARR in just 8 months. And after that, you can see Cursor, Wiz, OpenAI, Slack, and Twilio and Shopify doing their magic, right? So, that's how fast agentic AI companies are growing. And these are some of the headlines recently. Agentic AI startup Emergent raises 23 million Series A. Agentic AI startup Adopt raises 6 million in round led by Elevation Capital. This is some of the news. I just got a screenshot of these from 2024 to 2025 just to show you how these agentic AI startups are raising huge amount of money lately. So this is the evolution of agentic AI. Got it from Gartner. Like I said, it all started with simple AI assistants using simple LLMs, and then we saw simple AI agents with more task specificity and then autonomous behavior, and then came collaborative AI agents where different AI agents came together. Specialized AI agents came together to solve a complex problem or complex activity, and then with high agency. And then now we see now what we are seeing is a AI agent ecosystem where collaboration between multiple applications and organizations is happening. That's where we see MCP and all, right? So what is the goal of agentic AI? The goal of agentic AI is about increasing agency and specialization. So that's the thing. As you can see in the image, right? If you take x-axis for specialization and y-axis for agency, uh, you can ask ChatGPT to create a meal plan for you, right? It will easily create, but there is less agency and less specialization. It doesn't know your body type, it doesn't know your workout type and all those things. But when you have a personal assistant created by any model, you can automate it where you can tell it, hey, create a meal plan for me. It will say, here is your meal plan for you. Here is the meal plan for you. Can do it can do it for you weekly, monthly, and all those basis. But there is a more agency, but less specialization, right? It does the same thing. There is nothing special about it. But when you have a personal grad student who is specialized in nutrition and health, he can give you evaluate everything, and he can give you a proper plan. But there is more specialization, but less agency, since there is no agentic or AI agents involved. But if you employ agentic team, it can do much more than just your meal plan. It's also give you like, groceries will be delivered around tomorrow at 8 p.m. and all those. You can extend your whole concept to different levels. So that's why. So this is just wanted to show you how what is the goal of agentic AI, right? About increasing agency and specialization. So this is the journey to agentic systems, like LLMs to agentic systems. Like it all started with the client, and then the LLM response, and then came agent with structured enrichment loop that builds context, invokes tools. It takes its own actions, critiques, and then gathers human feedback and all those things. And then agentic systems were different, multiple AI agents coming together to solve a complex task, right? So again, agentic AI, the difference between a simple, very easy difference between AI agents and agentic AI systems. As you can see, there is one agent connected with all the tools, memory, and other things. In AI agent, whereas in agentic AI, there are different specialized agents coming together to help you solve a very complex problem or task. So a clear differentiation between agentic AI and AI agents. In the AI agents, you can see if you ask an AI agent, there is one AI agent that does everything. I want to book a trip. It'll say, sure, I will find the flights for you, and it'll just do the flights thing. That's it. It doesn't go beyond that. But when you have different specialized agents, one for flights, one for hotels, and one for share the plan and report. As you can see, I want to book a trip. If you ask the same, if you come up with the same prompt, the flights AI agent goes and finds the best flights for you, and hotels agent finds the best hotels for you, and also a combined agent will the orchestrator agent will combine everything and come up with a proper plan for your whole trip. So that's the difference between agentic AI and just using AI agents. So how tool usage basically works in agentic AI? As you can see, the user prompt comes in, hey, I want to know the weather in Bangalore. So it goes to the LLM, the brain of the whole system, and then the LLM thinks like, oh, I need to pick the weather tool, and it picks the tool, and then the tool execution happens, and it goes back to the LLM to finally produce or give you the final output. So that's how usually the tool usage happens in agentic AI systems. So you can also see, before we used to just say RAG workflow. Now we see agentic RAG workflow, right? So this is a simple RAG workflow where, the user query, like your own PDF. You can see in the downside there is a PDF, your custom document, which gets converted into embeddings using an embedding model, and all your embeddings are stored in a vector database. And then when a user query comes in, even that gets converted into embeddings using a embedding model, and then goes to the vectors DB to fetch the relevant chunks using vector search. And then now you have the query and the context. It goes through the LLM to give you the proper response. One thing you can observe here is it's very simple and there are no AI agents involved. But researchers thought, what if we involve AI agents here, right? So this is how it became. We started calling it agentic RAG. Why agentic? Because as you can see, there is an AI agent. There is an AI agent involved here. The user query comes in, and there are different there is an agent which can do apart from just the normal RAG. It can also do tool calling if required. It can fetch a lot of things and do tool calling, and all the whole the upper part you see is what we saw here. Then simple RAG along with the agent that can do tool calling, they can do reasoning, that can do take actions and all those things. That's why we started calling it agentic RAG, which is much more advanced version of RAG. And here is a simple multi-agentic system where multiple specialized agents come together to help you help you with any sort of complex problem that you have. If you ask, like, find a flight to New York, right? The orchestrator agent breaks this thing into subtasks, and each task will be given to a specialized agent. One agent is a planning agent, which plans everything, and then there is a booking agent which handles flight reservations, and there is a memory agent which is very useful, like, uses past history, user data and preferences, and there is a critic agent which validates final selection, price, issues, and all those things, right? And then again, the final orchestrator agent collects everything and basically creates a proper plan and gives back to the user. So again, simple differentiation between generative AI and agentic AI. Generative AI understands and generates new content, basically. Agentic AI it performs, understands, generates, and performs basically actions because it has access to the tools and all those things. Mm, Again, like traditional generative AI, the input is fill in the blank. The cat is sleeping because there is a LLM which it can generate. Generative ads, as the name suggests, it generates the new word using the probability. That's why there is a LLM involved. And then with agentic AI, there is an agent involved. You can basically say, build a web app using React.js. So it will go and basically do all the reasoning with memory tools resources connected. It can take its own actions, like, hey, use search. Step 2 is plan development. Step 3 is write code, and step 4 is review criteria. If you go to Claude and try to do this, it will do the exact same thing. I mean, it will give you properly. It will try to give you the code if you try to say, hey, build a web app using React.js. But if you use a AI agent, build a proper agentic AI application, it will give you everything. Like, it will use search, it will plan development, write code, and review criteria, and you can also extend it further. So these are some of the agentic AI frameworks. Today we are using LangGraph. There are many others like known ones like QAI, Autogen, and so these are some of the features. LangGraph has like graph-based workflows, real-time processing, structured data handling, memory management, everything is there. And then QA is like role-based design, task delegation, multi-agent collaboration, where multiple agents are involved. You can use QA, and there is Autogen from Microsoft, which is good with conversational approach, quick responses, modular design, supports planning. And you can also see best fit for agent type, right? So again, these are the agentic AI frameworks. Other than the we showed here, there is also, with code and no code, low code platforms. With code, there is LangGraph, Agno, Pydantic AI, QAI, Autogen, AG2, Agents SDK, Google EDK, and then with no code or low code, as you can see, BotPress, Make, N8, and N8 has become really popular. You can see many people using it. There is Watson X, Langflow, and all those things. But today we are using LangGraph. So I wanted to talk a little bit about LangGraph. LangGraph is again comes under the ecosystem of LangChain. So as you can see, LangChain is here to build very simple chatbots with the predefined rules, right? As you can see, A, B, C. The flow is one way. You can't do dynamic actions here, dynamic um, things here. As you can see, LangGraph, if the system thinks, hey, the user prompt is this, I think we should go to C first. So from A, if you use LangGraph, it can easily go to C, and then it can come to B. So that type of dynamic branching is available in LangGraph. That's why most of the folks, while building agentic AI applications, use LangGraph lately. So these are some of the components we need to know when we are using LangGraph. Nodes are nothing but what the agent does. The LLM calls tools and logic. Edges are how it decides what to do next, right? State is what it remembers and carries forward. So these are the three important components of LangGraph. So the journey so far is like it all started with the LLM workflow where user came, gave the prompt. There were rules, And then there is a model which gave you the output, and then came the RAG where we started giving a custom data to the whole system to make sure we build our own custom RAG applications, and the system doesn't hallucinate. And then came AI agents with all the planning, reasoning tools, memory with all the capability. And then now we see agentic AI systems with different multiple AI agents coming together to help you build complex systems, complex responses, give you. So this is a typical enterprise data architecture. As you can see, there is you know um, your customers might be running analytical workloads, and initially you feel like having olap database, and then in somewhere in between you get some customers who are running transactional workloads. You feel like having a oltp database, and now all the hype is all about Gen AI, agentic AI applications, and now you feel like having a vector database also. If you see, managing all these databases can be very complex for any data architect or any developer working in your company. It's very complex handling all these databases. So what we say at SingleStore is you can remove all and use SingleStore as your all-in-one data platform, because we have good integrations with different frameworks, and we can ingest, index, re-rank, and then we do filtering, similarity matching. Single store supports all types of data instead of using just a vector, specialized vector database, right? Single store started supporting vector storage, I mean, vector embeddings long back in 2017 itself. So now we see with all the hype of Gen AI applications, vector databases have increased in popularity, but single store can do much more than just using it as a vector database. So yeah, this is what we say, like you can use single store as an all-in-one data platform. Like I said, single store, using single store, you can build robust AI applications because single store has a good integration with LangChain, uh, Llama Index, Creo AI, data, because all these frameworks are very popular these days, and most of the companies are using these frameworks to build their AI applications basically. And SingleStore has a very good integration with this. You can go to different docs. If you go to LangChain docs and search for SingleStore, you can find an Llama index. Also, you can go and find Creo AI. Also, you can go and find similarly with free data. You can go to most of our articles and find different tutorials that we have created. So this is what we are building today, agentic AI travel app. So there is a user input, as you can see. Hey, uh, I want to go from Prague to Costa Rica, and this is the date, and this is when I want to come back, and I want two-bedroom hotel apartment, and this is my budget. And there are two tables that we're going to create: accommodation agent, and then accommodation um, table, and then the flight table. And there are two agents also here, accommodation agent and flight agent. The accommodation agent will go to all the booking booking websites to find the proper accommodations, and flight agent will go to the flight websites to find the proper flights for the user depending on his use input. And there is a summarizer agent that does and gives you the final report. All right. So we are using LangGraph here. So this is a simple AI agentic demo planner. This is the stack that I have. We have graph.py, we have main.py, state.py. These are different files. I'm going to show you exactly. I think, yeah, this is what it is, right? So we have different agents here, right? Cache agent, flight API agent, flights agent, recommendation agent, search agent, weather agent. And these are different agents that we have created, and database stores all our database logic. We are using single store here. And then main.py is the complete logic of how our application basically works, right? As you can see, runs the entire application, collects user input, invokes the LangGraph workflow, and prints the results. And then we have requirements.txt that has all the dependencies that we need to have, right? And state.py also maintain the state of the application, as you can see here, right? Central memory box for agentic system. So yes, so what we're going to do is like, first we need to have a single store account. You can use this link to create your account and get free credits. So what we're going to do once we have account, we create a workspace and a database to hold our data of flights and accommodations. We'll create two tables, accommodations and flights, to store the results and use as cache and start the agentic AI applications. And let's see how we do it. I already have my account. So I created, let's go to, yeah, let's go. So if you don't have a workspace, create one. Once you sign up and sign in, create a workspace. This is my workspace and create your database attached to your workspace. So travel AG is my database name. I have already created that. So I have, yeah, it's here. I have already created. So creating a database is easy. You just click here and create a database. So once you do that, go to editor and go to new, go to SQL file. And what you're going to do is, since we want, so this is the GitHub repo. We need to have two tables, accommodations table. You copy this and you copy this and you can run it here. But before that, make sure you are running it properly in with your connections, right? Specified connection. This is my workspace name and this is my database. And we're going to create a tables inside our database strategy. So we are creating accommodations table and we're also creating flights table. So once you click on it, say run, it will run. I already created. So if you go to database Travelg, I have already created these two tables inside my database. So once you do that, we can run the application and then you can see, right? So we have all the code here. Uh, so if I run the application python main.py, it'll ask me like, hey, origin, what is the origin? I'll say BLR. I'll say next destination, Mumbai. I'll say start date 2025, 12. Let's say today is 1723 and the end date 2025, 12, 26. So bedrooms, I want one bedroom and the max price per night for the hotel should be $100. Minimum rating for the hotel 4, and then it'll start doing its magic and it should give me the recommendations in a while. So yeah, should give. Let's wait for a minute and see. But before that, it gave here, right? Yeah, but yeah, this is how it goes. Yeah, we got the output here. As you can see, we said this and a Royal LM output, accommodations, name Hotel Marine Plaza, city Mumbai, country India, price is 98, rating is 8.2, minimum bedroom 1, this is the URL. So these are the, till here it was accommodations and till here these flights and it'll give you the end raw LM output. The temperature ranges between 23 degrees Celsius to 28 degrees Celsius in Mumbai at that time, and then these are the top orders and these are the top flights. So this is how you can basically modify and this is how basically different agents, as you can see, come together to solve a complex problem, right? And what we created was we created a travel planner basically. So it gave us a travel planner and If we go back to our travel AG database, and if you see accommodations, you can see all the data here, right? So yeah, I ran before also. That's why you see more data here, flights data, sample data. Yep. So you can change the destination, you can play with it, you can change the destination, you can change um, uh, the city name and all those things. So that's what we created, a travel planner. And this is the GitHub repo. I'm gonna share this. Maybe you, um, yes. And thanks, guys. And yep, that's about the tutorial part. And if you have any questions, let me know. I
All right. Thank you so much, Pavan. And folks that are attending live, we are finally open for the Q&A. So if there's any questions that you might have, now is the time to ask. And if not, we will also follow up with you guys on email. And, we will be sharing Pavan's GitHub repository there. And, you can like follow along in real time and make the best use of the resource that we are going to provide you. And yeah, like once again, SingleStore is providing $600 worth of free credits, which last a pretty long time. You don't need to put any credit card, and like it's pretty seamless to set up your account. So if there's any thing that you found useful from today's session, please feel free to set up your account. And if there's any issues that you might encounter, always reach out to us. And our DMs are always open. You can reach out to us on LinkedIn. I go by the name Yukti Divedi, and Pavan has a pretty huge following on LinkedIn, so you can always reach out to him. And yeah, like that's it for today's session. Please keep an eye out for our follow-up email that you will be getting in your inbox shortly, and it will have all the resources to today's session. So if you skipped any parts, uh, please don't worry about it, and we all have you covered. So yeah, like we have amazing future sessions that are going to be coming up in the next few weeks, and we have an amazing plan for 2026. So stay tuned for that. And if there's any questions, uh, again, like feel free to email me about the webinar plan. If you're interested in doing a webinar with us, I'm all yours, because I'm the right person to message about that. So yeah, like that's it for today. So if there's any feedback, you can always revert to our email. And yeah, thanks for attending and have a great rest of the day. Pavan, do you have anything to cover? Like, if there's
No,
anything
no,
else?
that's it. Thanks, guys.
Okay.
Thanks for joining.
Yeah,
Thank you.
thanks everyone for joining, and please reach out to us if there's anything that you might require us just assistance upon.